On July 2, 2025, a signal arrived. Within minutes, every gamma-ray detector in the solar system had flagged it. A gamma-ray burst, the most powerful type of explosion the universe produces. They happen roughly once a day. They last seconds, sometimes minutes. This one did not stop. 1 hour passed, then 3, then 5. At 7 hours, the signal was still firing. Nothing in 50 years of gamma-ray astronomy had ever lasted this long. Some instruments had to be recalibrated mid-observation just to keep recording. And the signal did not arrive as a single, sustained blast. It pulsed 3 separate times, 3 distinct peaks of intensity across its 7-hour span. That should not happen. Gamma-ray bursts destroy their source. There is no second pulse. And yet, this one fired 3 times from the same point in the sky. When telescopes around the world finally converged on the source, the answer demanded something that had never been observed before. Something had been hiding inside a star. The event was catalogued as GRB 250702b. It is the longest gamma-ray burst ever recorded. Of the roughly 15,000 GRBs detected since 1973, none come close. The previous record was about 4 hours. This one nearly doubled it, and there was another detail that made it stranger. A day before the gamma-ray signal arrived, a Chinese X-ray telescope called the Einstein probe had already detected X-rays from the same location. The process had already started. Whatever produced this burst had been active for at least 24 hours before the main explosion even began. The X-rays were quieter, dimmer, like pressure building behind a wall. Then the wall broke, and the gamma rays began. The James Webb Space Telescope was directed to observe the source. It traced the signal to a galaxy more than 8 billion light-years away. A galaxy more than twice the mass of the Milky Way, buried behind enormous amounts of dust. The burst had originated in a star-forming region near the edge of that galaxy, far from the supermassive black hole at its center. Whatever caused this was not a galactic engine. It was something embedded inside a single star, 8 billion light-years away. To put that in perspective, the light from this explosion left its source when the sun did not yet exist. It traveled for longer than our entire solar system has been alive. And when it finally arrived, it carried a message that no existing model could decode. How do you power a gamma-ray burst for 7 hours? Astronomers know 2 mechanisms that create GRBs. The first, 2 neutron stars collide and merge, producing a black hole that launches jets at nearly the speed of light. These bursts are short, fractions of a second. The second, a massive star exhausts its fuel. Its core collapses into a black hole, and the collapse drives jets that punch through the dying star. These last longer, seconds, sometimes minutes. Neither mechanism can sustain jets for 7 hours. A collapsing star simply does not carry enough rotational energy. Every known model fell short by orders of magnitude. The energy released in gamma rays alone was equivalent to trillions of years of the sun's total output, compressed into a single event. Whatever produced GRB 250702b had access to a reservoir of energy that no single collapsing star could provide. It required something else entirely. One explanation, published by a team of more than 50 astrophysicists, begins millions of years before the explosion. 2 massive stars, born together in a binary system, orbiting each other. One of them dies first. Its core collapses and becomes a black hole, a few times the mass of the sun, with an event horizon just miles across. The star is gone, but the black hole remains in orbit. What is left is a quiet binary, a stellar mass black hole and its surviving companion, a stripped helium star that has already shed its outer hydrogen layers. For a long time, nothing happens. They orbit, but the helium star is not stable. Over time, it expands. As it swells, the distance between them closes. The black hole spirals inward. Material from the star's outer layers begins to flow toward it, forming a disk. What does a star do when something is pulling it apart from beside it? It keeps burning. It has no mechanism to respond. And at some point, gradually, over weeks or months, the black hole crosses the surface. It enters the body of the star. Imagine the scale of what happens next. A black hole just miles wide, submerged inside a star dozens of times its own mass. If you could watch from within, you would see nothing. No visible object, no surface, just a region of space where light and matter curve inward and vanish. But you would feel the effect. The surrounding plasma distorts. A spinning disk forms. The black hole does not destroy the star instantly. It sinks toward the core, accreting material, building angular momentum, and launching jets of particles moving at over 99% the speed of light. Those jets drill through the interior of the star and blast outward into space. This is what the detectors recorded on July 2nd. Not a single explosion. A sustained process. A black hole consuming a star from the inside, powering jets for hours. The 3 pulses the instruments recorded may correspond to phases of this process. Changes in accretion rate as the black hole encountered denser layers and the star's internal structure buckled around it. If this model is correct, the energy released should eventually tear the star apart entirely. The helium merger model predicts a supernova. Astronomers pointed Webb at the site 25 days after the burst. They found no supernova. But the galaxy was choked with dust, and the distance was immense. If the explosion happened, it may simply have been too faint to see through 8 billion light-years of cosmic dust. The proof, for now, remains hidden. Explanations have not been fully ruled out. The cause of GRB 250702b is still, formally, an open question. But the helium merger model fits the data better than any alternative. And if confirmed, it would mean something profound. But what GRB 250702b has already revealed is significant on its own. For 50 years, astronomers knew 2 ways a gamma-ray burst could form. As of July 2025, there may be a third, and it begins not with a collapse or a collision, but with something quiet, a companion that was already there, a black hole circling closer, year after year, for millions of years, a star that carried the instrument of its own destruction in orbit beside it, burning steadily the entire time, with no way to know what was coming. By the time the distance closed, the outcome was already decided. The signal lasted 7 hours. The process that created it had been building for longer than human civilization has existed.